Okay, and welcome to the second webinar series on App Inventor. Today we are going to be talking about some basic concepts of programming, we will just go through a number of these in using a demo app that I will make available to you, and we'll link to it in the description below this video. Before we dig into that, though, I want to show you this app that we're using. So here again, this is a screencast of what is showing on my Android device. So I have a phone in front of me, and this is the app that's running. And screen one, as you'll see, has a number of buttons that then navigate to different pages, and then on each screen there's a back button so that I could get back to the navigation screen. So I wanted to point out that this is a very common pattern where you'll have kind of a navigation screen that then links out to other screens. And how you do that is basically with this event handler. When any button is clicked, then you will then open another screen, and then you will set the screen name. So where that is located is in the control section of the blocks, where you could see here close screen with value, open another screen with screen name, and so you will use that a lot, and so that's basically how you navigate from one screen to another. The other thing I want to point out, and this is very important, I mentioned it in the first video, but it begs to be repeated over and over again, is screen one will always be the screen that loads in your app. So be sure that when you are programming your app, screen one has the screen that you want to be shown first. Otherwise, if you try to go back and change that, if you say, for instance, your second screen you end up putting as screen one, and then you need to add a loading screen later, you'll end up having to move your code around, and it's just really frustrating. So just be sure that screen one has your loading screen. Also, you can't rename this. To my knowledge, it's basically screen one is required for your app to work. So just I wanted to point that out again. So with that said, let's begin talking about programming fundamentals. The first thing to note is that programming, the essence of it is it boils down to manipulating data. That's all it is. Either you're saving data, you're reading data, you're updating data, or you're deleting it, or you are performing some type of operation, like a mathematical operation. So in any programming language, you have what are called data types. And in App Inventor, it supports 3 data types. The first data type is numbers, which are represented by this math section here. So here you can perform any type of mathematical operation that you might need for your application. So you have 2 types of numbers. You have what are integers, and then what are traditionally known as floats. So integers are any whole numbers, 1, 2, 3, so on and so forth. Floats are any kind of number that have a decimal point and numbers following that. So 1.5, 3.14, etc. Those are considered floats. So numbers, the number data type in App Inventor is again, you'll find it in this what they call the math section. The second type of data type in App Inventor are known as strings. So strings basically are any type of alphanumeric text. So they could include characters, like letters, and numbers. So for example, a first name, an address would be a string, a phone number would be a string, or a zip code would be a string. Now, I mentioned phone numbers and zip codes because it's often people think because they're numbers that you should make them the number data type. However, you only use the number data type when you want to perform calculations on data. So phone numbers, you're not performing any calculations. Zip codes, you're not performing any calculations. So you would traditionally use a string for that. And then the third data type that App Inventor supports is called Booleans, and that you'll find in logic. Boolean comes from the concept of Boolean algebra, and the reason it's called Boolean is because the guy that developed Boolean algebra, his name was George Boole, so that's why we call it that. But basically, Booleans are simple logic constructs, true or false. That's it. So any variable that is a Boolean, it's either true or false. So you perform various logical operations on that, and we'll see in a minute how that works. So first, let's go into the numbers. Let's experiment with the numbers data types. So here you'll see that I basically programmed a simple calculator that where you enter one number, you pick your operation, and then you enter another number and you calculate. So let's go to that section of the code. We'll go here in numbers. And here's basically where all that logic is kept. So what's really nice is you could collapse and expand blocks in App Inventor. So as you can see, when your screen gets cluttered with a number of different blocks and it's hard to see, you could easily just right-click on a block and collapse it, so you can make room for yourself. So that's what's going on there. So I will demo this part of the app. So here we'll enter a number. We'll say 4. We'll keep it at plus. You'll see here you could choose plus, minus, multiplication, or division. So we'll choose plus 6, and then calculate, and then it gives us a result of 10. And we could do that with any of the other operations as well. So what is happening here? Basically, if we look at the designer, we have a few inputs. We have these text inputs for the first number, the second number, and then also this drop-down list, which basically, as you see here, we have added which operations you could choose from. And then finally a calculate button. So how this works is in the blocks, if we go here, when we hit the calculate button, it will look to see which operator was selected. So it goes if operator selection equals plus, then we are going to perform an addition. If it equals minus, we're going to perform subtraction, multiplication, division, etc. So this is pretty straightforward. And again, these blue blocks, excuse me, doing the operation, that is just found in the math section. One other thing I wanted to point out about this is you'll notice that this first if conditional, it's checking to see if the text that you enter is a number. That is called data validation, and it's a very good thing to, well, it's a required part of programming, really. Anytime you have any type of user input, you want to basically check to make sure that the user is entering the type of data that you require to perform your operation. So, for example, if I add some type of text string like that and hit calculate, it's going to say cannot accept the arguments, or let's see, we'll say g plus y calculate. You can only enter numbers. Okay, so if you don't enter numbers, then it's going to give you a warning there. So the moral of the story here is to always validate your input with something like this. Now, fortunately, App Inventor makes it real easy for numbers to validate with text blocks or text inputs. If you click on the text input, you could actually select numbers only, and then this will only allow numbers. However, I just wanted to add this in here as a way of, to show you how to manually do that. However, there's other types of validation that you might want to do. For example, if you want to validate a zip code or validate a telephone number to make sure that it's in the correct format. So there's many different things you might need to validate before you actually accept data or do anything with it. So this is just an example of input validation. Also, you'll see that there's this modal box that's popping up that gives you the results. What that is actually this notifier. So in the interface builder, you will basically drag a notifier into your screen, and it'll pull up as a non-visible component. This is very helpful, again, for either showing the user some type of message, or even just debugging. So while you are developing your application, sometimes you need to see how a value changes over time throughout the execution of the code, and you'll just throw these notifiers in there as a way to kind of debug your code and see what's going on. So be sure to use that while you are developing your application, because that's an essential part of building any kind of program. So that's numbers. That's pretty self-explanatory. It's the math section allows you to do any type of mathematical operation, obviously. So and you could get pretty in depth on that. So let's return to the home screen here. Next, we're going to talk about strings. So as I mentioned before, strings are alphanumeric characters. So strings are the data type that contain letters, numbers, and characters. And it's one of the most commonly used data types in App Inventor. So we'll go to the string section of the code here, and as you can see, this is what the interface of the app looks like here. The strings data type has a number of different operations that you could perform on strings, and you could find those in the text section of the blocks. And so you could do things like compare text. You could trim, which basically removes any what's known as white space. So if there's a space on either side of a string, it'll just remove that. You could change text from lowercase to uppercase and uppercase to lowercase in this instance. You can find where a substring of a string is located. So, for example, if you have a name like John Doe, you can search for Doe within that string, and it'll tell you at what point, using a number, where that string lies. And we'll show you that in a second. Contains text. You could see if a string contains some type of other string. You could split text at certain characters. For example, if you have a list of cities that are separated by a comma, you can go ahead and split those out and separate them out into a list. Split at spaces, same thing, but just with spaces. Segment text, you can basically take a certain segment of a text where you're given the text, you give the starting position, 1 being the first letter or first character in the text, and then 1, 2, 3, so on and so forth, and then the length. So you could just grab a piece of a string. You could replace text. You could say, if again given the example of John Doe, I want to change it to Jane Doe. So look for John and replace it to Jane. Obfuscated text, that's for cryptography based, or I should say encryption, but it's I would not use this. Stay away from that. And then this logical operator called is a string. So you could say, okay, well, is this variable a string? If it is, it will return true. If not, for example, if it's a Boolean, it will return false. So those are all the operations, and I will demo several of these in the app here. Let me close this. So this screen has a text that you enter, a section for finding text and replacing texts, and you could choose your operation and then evaluate. So this long block basically goes through each of these cases here. So let's go through the first one. Let's say today is Monday, so we will say Monday, and I will make that all uppercase. Evaluate, and it'll change Monday from title case to all uppercase. Then lowercase, that just does the opposite. Let's say get length. If we select get length and click evaluate, it gives the length of the string. In this case it's 7, and it's 7 because I have a gap there. So if I remove that space at the end and evaluate, I should get 6. So there's an example of when you should use the trim operation. So if you are having users enter data into a text field and they accidentally enter a space, you want to kind of sanitize that text by running the trim operation, and it'll just remove that. Let's see, the next operation we could use is split at comma. So here we'll do what's known as a comma separated list, and I'll say Monday, Tuesday, Wednesday, and then I will evaluate that, and it will list Wednesday. It'll go from the back to the front. So Wednesday, it'll say Tuesday and Monday. So what happened here, and we'll look at the code here for a quick second, is it creates an empty list. And we're going to go into lists in the next section, but it creates an empty list, and then it will append the days to the list after it splits out the texts at comma. So it says, okay, for each comma, go down this string and give me the text that is in each comma, and then add it to a list, and then we're looping over this list and printing out that message onto the screen. So we're going to get into loops and lists in a second, but here's an example of one in action. So this is a very common way of importing and exporting data, is using a comma separated list like that, and so splitting strings at either commas or spaces or tabs is a very common operation you'll do in programming. Let's see, the next operation, find substring. So let's see, we will say John Doe, and we'll say, let's make sure I have find substring selected, find text and Doe. Let's see, evaluate, and it'll say 6. So 6 is the index number of where Doe starts. So J being 1, O being 2, H being 3, N being 4, the space being 5, and then D being 6. So that's why we return 6. It's giving you the position in that whole text string of where it occurs. Now, be aware that this operation is case sensitive. So if I say, not Doe, done, but Doe, if I do that, I will get a 0. And 0 means that that text was not found within the whole string. Let's see, what's the next? The next operation is empty. So this is another good one for data validation. To make sure that any text field that you have that is required, make sure that that is empty returns false. So that users will always have to put in a text field. So, for example, if you have a user registration and you need their first name and last name, those are going to be required fields. So you want to check those those inputs to make sure that the field is not empty. So if I evaluate is empty, and it'll say text box is empty. Now if I just add some data in there and evaluate, text box is not empty. Again, so that's a very good one to know. And then finally, replace text. Let's see, we'll go back to our John Doe example. And John, we will change, let's see, find text, we will look for John. Again, this is case sensitive, so make sure you do that, with a capital J, and then replace text. And we will, John is now Jane. We will evaluate, and it says Jane Doe. So it looks for John, removes John, and adds Jane. And that, again, is something that is very common when you're working in programming, is to replace text within a string. With that said, we will move on to conditionals, or excuse me, Booleans. So Booleans, as I mentioned before, they are simple true and false values. Those are the only two values that a Boolean variable can have. So in a way, it's kind of the simplest data type. And often Booleans are used in conditional statements, which we'll talk about next. But this if then or if else statement, known as a conditional. So if something is true, then go ahead and perform that operation. Otherwise, do something else. So where it gets a little confusing sometimes for people is when you use these operators here, where things like and or. What I built out here is an example of how these things evaluate in programming languages. So when you use and, both sides of the equation have to evaluate to true in order to be true. So that logically that makes sense. But sometimes when you chain these together, it could get kind of confusing. But this is a very simple example of using and or with the various values. So true and true should evaluate to true, and it does. So true, good, that worked. True or true, again, should evaluate to true, and it does. And so or, in this instance, either the first value or the second can be true, and it will always evaluate to true then. True and false, this should be false. Okay. True or false, this should be true. Yep, and true. False and false, that will be false. And then false or false, that will also be false. So again, this is pretty logical, pretty straightforward. Again, you'll find all of this in the logic section, and how this particular demo is programmed is it's checking for which one of these is checked, which is basically I have a bunch of check boxes here, true and true, true or true, and depending on which one is checked, then I am evaluating that using the logic operators here. So true and true, we'll have true and true here, true or true, true and false, so on and so forth. All right, so next we will talk about conditionals. As you may have noticed, a lot of the examples that I've been showing already have conditionals in them. This example isn't really much of a departure from some of the examples that I've shown. However, I wanted to show a couple different things to note about using conditionals. So conditionals are essentially these if then else statements, and often you're just a simple if then statement will work for your what you need to do, but it's important to note that you could nest these. So here in this example we have an if that checks if the user input is a number. Again, this is going back to data validation, and if it's not a number, then show alert and tell the user to please enter a number. If this is a number, then it's okay, we could process that data and we will then do a check, and you'll see that this if then else statement here is actually nested within this if else statement. So you could nest them, and that's fairly common. I would recommend not to nest them more than 2 or 3 deep, because once you start to get deeply nested if statements, it becomes very difficult to read the code and kind of pick it apart. So it's best to keep these nests shallow, and if you find yourself in a position where you're having to nest deeply, then you probably need to rethink your code. So a couple other things to note about this example. Well, before I do that, I should mention that ifs, the conditionals are in the control section. So if we pull out if then here, you'll see that there's also this little gear icon here, and if you click on that, that's basically how you add else if statements. So I'm going to drag that else there, and it'll click into place, and you can add as many of these as you need. I should say if there's only one else, we'll say else if here, and this could go on for however long you need to check any type of or to evaluate any type of data here. So that's basically how you build those. Now this program here, what it does is there you enter a number and it evaluates whether or not a random number generated from between 1 and 100 is greater than or less than. So I'll choose 5, evaluate. 5 is less than 56. Okay. If I put 89, evaluate. 89 is greater than 17. So it's a contrived example. However, it demonstrates a couple of important concepts, namely the nested if, also data validation here. And this is a good way to kind of build out your validation. Is it put in the first if, check if you're getting the data you need, and then you could, any other logic that you need to execute could then just be nested into this else statement. The other thing that's going on here is we are using this math method called random integer. So this is a very helpful function to call, especially when you're building out games, because it's often that you need to generate random integers. So that's available in the math section here. And then finally, I wanted to point out this this thing that says initialize local variable. So I haven't mentioned this yet, but variables are really essential to programming languages, and variables like in algebra are basically a name for a piece of data that can change value over time. So an example of a variable name would be first name, to hold a person's first name, or last name, to hold a person's last name. So any data that you need to store so that you could then reference later in the program, you're going to declare a variable. And so there's this special section here called variables, where you initialize variables. You could get them or set them. Get them just means you're going to read them into the program. Set them means you're going to change their value from what it was prior. But the one important distinction to note here is you have this thing called global variable here, and then you have this variable here that says initialize local variable. And there's a section in the Technovation curriculum that describes the difference between these two. Global and local refers to what programmers call scope. So there's global scope and then there's local scope. Global scope, it basically means that variable, if you assign a variable to global scope, it's available to be read anywhere within the program. So if I have a global variable here, I could use it anywhere within these blocks. Now, if you're using a local variable, like here, random number, this local variable can only be used within this this block. So it says initialize local variable random number, and then it says in. And so random number, if I had another block out here that wasn't nested within this initialize local, I could not access random number. So that's the main difference. And it's best to try to use local numbers as much as possible, or local variables as much as possible, so that you don't cause any variable collisions. But we won't get into that. Just note that local variables are only accessible within blocks that are nested within it, and then globals are just available everywhere within the program. Okay, so that's a pretty simple, straightforward program. We'll exit out of here and talk about lists and loops. So lists and loops are another important concept in programming, because basically, like as I mentioned, you're manipulating data, and a good way to store data is in a list, because you could add to the list, you could remove from a list. So let's take a look at what's going on here in the user interface. Basically, I have a text input and then this add item button. And so what I'm doing is I want to type in some text here, click add item, and I want it to add it to this list view. So this here, you'll see, is this list view. And that's what this is a pretty simple example of like a to-do app. And in the Technovation curriculum, that is one of the assignments, is to build a basic to-do app. So let's zoom out here. Let's see what's happening. So let's take a look at this add item. So when I click the add item button, it says add items to list, and it's getting global list items. So let's see if we could find that. So here again, a global variable called list items, and we initialize it to create an empty list. So that's what we're using to store our list items. Once you add the item, it says take whatever item you typed in the text box, set the text box to empty, because that will clear the text box, and then set list view elements to get global lists, get global list items. So I will demo that here. So this is a to-do list. So today I need to walk the dog. We'll add the item here. You see it adds it to the screen. I need to buy groceries. Add the item. And then I need to grade papers. Add item. Okay. So here you'll see that it just adds it to this list on the screen. Just to kind of demo a few different operations that are common. Often when you have a list, you'll want to do what's called a loop through it. So here you say you have this when loop list click. Zoom in here so you can see it. If the list is empty, then it shows a notice your list is empty. So I'll show that in a second. But if I click on this loop through list, what it does is it will go through all of these in the list and output it. And so that's what this for each item in list, get the list of items and then show an alert. And then also I'm performing some operation here. So what I'm doing is I'm getting the length of the item. So that number that you see here is basically the number of characters that are in there. So buy groceries and then grade papers. So that's this for each loop is how you would go down a list of items and perform some operation. In this case, counting the number of characters in that string and outputting it to the screen. Another thing you would do is you might want to add an item at a certain point in the list. So here I will say, let's see, take out trash, and then I'm going to add a comma here to add the position I want it to. So let's say I want to put it after walk the dog. I'll put 2 and add item. And let's see, that did not work. Why did that not work? Let's try this again. Trash. Okay, it appears I have a bug in my code. Oh wait, silly me. So I'm pressing add item, that's why that happened. So trash, comma 2, done. What I need to do is press this insert at index. So that 2 is the index that I want to insert it at. So if I press insert at index, Alright. It's supposed to put it here. That's right. Now I remember. Okay, so if I click OK, you'll see that it added it right after walk the dog. Okay, so this insert after index says, click show text message, add new item, title new item. Okay, so it calls this text notifier, and then it performs this operation here. So again, it new item with index, create item list. It appends to this list, so it's taking the new item that you added. It's splitting it into 2 lists, so it's taking the item like trash, and then it's taking the number and 2, and it's splitting it. Then it says insert this item into the global list. So select list item list, get item with index, index 2, and then select list item with index 1. So in the example that I just entered, trash comma 2, it says it gets the index, which is 2, and then it gets the item, which is trash, and then it inserts it into the global list item, and then sets the list view to list item. So it's a little hard to kind of read if you're not used to using lists, but this is essentially what we're doing. Is we're saying, okay, find take the input and then insert it into the index that you want it to be positioned at. So so play around with that, and once you get the hang of it, it starts to make a lot more sense about what indexes are. Indexes are essentially just the position within a list. And then the other thing that you do often with lists is you delete things from a list. So let me zoom out and see. So we have this here, list view after picking. So this is an event handler after picking that says after you click on one of the items in the list, go ahead and remove it. So it says remove list item from global list item, where it's the index, right? So if I click on buy groceries, it'll delete it from the list. If I click on grade papers, it'll delete it from the list. So that is the general idea of lists and loops. So we'll go back, and then we will then finish up on the concept of functions. And so it's common, so for functions, it's in App Inventor, functions are actually referred to as procedures. So in almost every other programming language, it's known as functions. Some of them call it procedures, but here functions are referred to as procedures. Now, functions are a very powerful way to prevent rewriting code over and over again, basically repeating yourself. There's this concept in programming called DRY, which stands DRY, means do not repeat yourself. So let's take a look at this functions here page. So here we have two text boxes and two buttons, and again, this is a contrived example, but what this is supposed to demonstrate is you have two locations within the interface that you need to perform some type of operation, and in this case, whether or not a number is prime. And so the one way to do this, and I'll demonstrate the not so dry way of doing this, is you have here button 1 and button 2, and basically they are running the exact same code. This is an identical copy of this. So why is this bad? Well, it's bad for maintenance reasons, because if you need to change the operation of something, if you have some type of business rule that requires you to change the way the program works, then if you change it here, you're going to have to remember, hopefully, to change it here. And so what would be better is if you had this operation isolated in an area that you could then reuse it in a number of different areas. So even though, you know, this works, right? So I could put in, oh, excuse me. All right, I could put in the number here in prime. 2 is prime, okay? Well, that works. Let's see, 7. Is 7 prime? Yes, 7 is prime. 8, no, 8 is not prime. Same thing, so that works here as well, obviously, but say I had a bug in this, I'd have to, again, remember to change it elsewhere. So a much better way to do this is to create a procedure. And zoom in here. This procedure is called IsPrime. So it says IsPrime, and it will return either true or false. So we will set the initial state to true. We will always say a number is prime unless we find a factor besides itself and 1. So we will run this. We will go through every number from 1 to the number itself, and then if if true equals true, then we will run this and try to find the prime. So get number, if this does not equal number and, yeah, okay, so for example, if it's 3, if this iteration isn't number 3 and it's also not number 1, then we'll run this, and you try to find the remainder of the number divided by whatever number we're iterating on. And if it equals 0, then we know oh, okay, well, we have a factor of that number. So if you enter 4, eventually it will get to 2 and see that 2 is a factor of 4, and then it will set this to false. A prime would never get to this this part of the code. So we've basically pulled out the operations you need to determine if a number is prime into this function IsPrime. Now we created the function, now we'll have to call it. So let's I have this already set up here, so let's actually change this. Let's get this out of here. And we're going to replace all of that code with this. I'm going to get this out of here. Duplicate that. Now you'll say, oh, well, here you're still duplicating code. Well, yes, I mean, there's inevitably you're going to have some duplication in a situation like this, but this is much more manageable than this long nesting, this long block that you're copying all over the place. So when anytime the general rule is anytime you find yourself repeating blocks of code more than 2 or 3 times, you should definitely pull that logic out into a function so that you could then reuse that, so that you are not repeating yourself. It makes the code much more maintainable. Other than that, that is essentially the foundation of programming. Data types, manipulating data using Booleans, conditionals, if-else statements, looping through lists, and then finally not repeating yourself with functions. So with that said, that concludes this webinar on programming fundamentals. The next webinar we will actually build out a more fully fleshed out, much more useful app using these concepts that we went through today, and we'll take all of these concepts and put them together to build out a much more kind of useful app. Other than that, thank you for watching.